get a video recorder, because the overhead projector is how I taught here for the first year and a half, is using it. And I projected it onto a smartboard just like I was doing.
It seems easier using that.
A little bit. Now, what we want to look at first here, and what we're looking at today, and today's main lesson is going to focus on, is side-side-side congruency. If we have three sets of congruent sides in two triangles, then the two triangles are congruent to each other by side, side, side. Now, I'm not going to worry about the proof. So the proof that is going to be required is not going to be like we had in the last chapter, in the other chapter where we went through and did the two-column proof all the way down. But what it will ask is that, and we'll see it here, is can we state that these two triangles are congruent? Because let's see what we have. These sides are congruent, yes? These two are congruent. And because the middle side is shared, these three sets of sides, we do have three sets of congruent sides in the two triangles, yes? So this is number 2. So this here would be side, side, side. So we can say yes by. Now, here comes the proof part of it, quote unquote. Because what do we know that is congruent? Well, we know AB is congruent to what? CB or BC, yes? That's one of the side lengths. What else do we know is congruent? Is congruent to? This right here would be the proof. Because you're just justifying why we know that it is by side, 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 is I have three sets of sides that are congruent to each other, so the two triangles are congruent by side, side, side. Now it might also ask on the test to write the congruency statement, which is angle, so you can say ABD. Triangle. So we want a long side with one inside. So I need to start on the other one.
Okay, so how are we going to
Any questions on this here? Now, once we get all of these done and we figure out which ones work, and they're asking us how can we prove that the two triangles are congruent, we're really looking to see what do we have. Because so far we can prove it by side, 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 and side, angle, side. So if the two triangles are set up like they were yesterday, we had a side, an angle in the middle, and then a side, okay, then we can say that they're congruent by side, angle. Here, when we look at this, we see what is congruent. Well, all three sides. These sides are congruent. These and these. Since we have three sets of sides that are congruent, we're going to solve it by, or say it's congruent by side, side, side. By side, side. And we know that B is congruent to. Yeah. Then we also have that BC is congruent to DE and but that's it. We don't have to do the congruency statements because it's not asking for it, but this is because, and state how you know, well, by side, 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 because we have three sets of sides that are congruent. And that's it. Questions on this here? The next one. So we do have angles, and it could work out if we had it in the form of side, angle, side. So if we look at this here, these sides are congruent. These angles, we have a side in the So here we do have SAS, yes? Now if we look at as we started off with CB, the side with 1, we'll need to start off similarly. So we go A to B and then B to D. So we have SSA. Do the two statements match up? Nope. So are these congruent? No. And I think we actually had this exact one yesterday. Let's look at this one here. Decide whether the congruency statement is true. Explain your reasoning. So why can we say that this is true?
All sides are consistent because of the
Yes, so
yes.
S and S. So we can say that DG is congruent to HK. DF is congruent to J. And FG would be congruent to JK. Yes. Side, side, side. Questions on this here? Okay. Okay. And surprisingly enough, when I first got here, I didn't let y'all use the review sheet on the test. Let's see this here. So do we have any sets of sides that are congruent? And the 9 is congruent to itself, yes? So how many sides do we have congruent? 2, yes? We need how many? Or we need 2 sides and an that is included or in between the 2 sides. But we don't have any angles. They're not told to us. And we have sides. So can we say these 2 are congruent? No. So for any of these here, when we're trying to say 2 triangles are congruent, we're going to need 3 pieces of information. Either 3 sides, 2 sides of an angle, or 2 angles and a side. Now we already know, because we saw today, if we have 3 angles that are congruent, well, it doesn't work. Could they be congruent? Yes. But they could also not be, because we don't have enough information to be able to determine it. Because these 2 sides are congruent, so QT is congruent to TR, yes? What other side? PQ, yes, is congruent to SR. Any others? PT would be congruent to. So because of this, we can say yes by side, side, side. Questions on this here? So, decide whether the congruency statement is true. Explain your reasoning. So can we say these 2 triangles are congruent?
Yes.
Exactly, it is no.
What?
Let's look at the statement. So what does the the congruency statement say? So A, B, C, yes? is congruent to DBC. So DB, is it drawing out the same triangle?
Oh, no.
So can we say that this congruency statement is true? No. Now, are these two triangles congruent? Yes, they are congruent by side, side, side. But it shouldn't say triangle DBC. It should be triangle BCB. And if one of these does show up on the homework, because we can say no, it should be triangle ABC, we could say that triangle ABC triangle is what it should be, if it does show up on the homework. A little bit. So if this type of problem shows up on the homework, wink, wink, hint, we can say no. We'll do this here. No, they're not congruent. This is what it should say. This is what the congruency statement should be. Questions on this here? So let's just make sure that it's right. So we go from J to K to M, L, K, yeah. Side, side, side. And I mean, we could say that JK is congruent to LK or KL. Both of those work. We can also say KM is congruent to what? Because it is shared in both figures. And then JM congruent to. And those would be our three sets of sides. Any questions on this here? I think you all feel comfortable with this here. Let's look at the last part. State what additional information is needed to be able to say that these two triangles are congruent by side, side, side.
The angle of CX and RT.
Because we need three sets of sides. Well, we already have that these sides are congruent. So we're missing a side, yes?
Yeah. CX and RT.
Because we're missing that side. So the additional information would be that RT needs to be congruent to.
RT needs to be congruent to CX.
Questions on this here? Because I think we have 16 and, what is it, 16 and 13 left. Which one do y'all want to look at, 16 or 13? 16? We can do 13 then. Because I'll confirm 16 here in a minute. So 13, if we look at this here, we are already given that ZZ and XY are congruent, yes? And XZ would be congruent to itself. So DX and ZY would be longer missing. So we would need to know this is congruent to ZY. Let's try to run that again. ZY. Because if I knew that these two were congruent, then we can say that the two triangles are congruent by side, side, side. This one here, we would need to know that GE is congruent to. Yeah, because we could have also said G is congruent to YW or any of those two. That's it. This here, so 3.6, we're finishing up the shortcuts. So tomorrow, we're going to be looking at these three here. Now, we've said already, because out of the 6, I've said 4 work, 2 don't. So far, 2 that work and 1 that doesn't. So out of the 3, 2 of these will work, 1 of them won't. And we'll see which one it is tomorrow.
That we should take votes.
Take a prediction on which one you think it is. Now this one here is just the properties of the triangles that show that this one is more stable. So we're not going to worry about that problem. This here is your assignment for today. 3, 4, 7, and 19. Luckily, I do have it over there.